crazy languages and the same marriage, because we in fact won't touch any crazy parts of either Perl or TeX. I will tell you a bit about them, what the role can each of them play in this marriage, and what to do not to get involved into those crazy parts and have some silly results. This presentation is not very technical, not very deep, just wanted to show you some nice happening of a few technologies and how it saved me some headaches in my work at the academia. Okay, so let's start. The outline is pretty short because first you need to have some introduction into those technologies, and then I will show you a case study, traffic jam report we were preparing for with cooperation with industry. Just to calculate how long on average the drivers in Warsaw spend in traffic jams, how much does it cost, and how much pollution of the air and so on. So, to start with the introduction, first of all, what is Perl? No, I'm just kidding, of course, because but this is also a warning to you, and to me also, just to tell you that more often I have the presentation the opposite way. I have to tell everyone what Perl really is, and in academia everyone knows what TeX is, so I don't tell anything about TeX and tell everything about Perl, and try to sell the language to all those newbies, but people who are really trained in laying out the documents. So if I switch the roles, just remind me that I should not tell you anything about Perl, because you know much better that language than I do. But if I skip some knowledge about TeX, you understand, just ask during the presentation. So what is TeX? TeX is, in the words of its creator, Donald Knuth, a new typesetting system intended for the creation of beautiful books, and especially for books that contain a lot of mathematics. And this is the quote from around the 70s, the years when the TeX was made, because the situation then was pretty much different than it is now. Now we have a lot of typesetting getting done in our computers. We have a lot of word processors and desktop publishing systems and so on, but in 70s it was pretty different, especially in publishing in academia. When you wanted to publish a paper from, for example, physics, which contain a lot of math, a lot of equation, you send the paper to the company who would make some corrections, some proofreading, and every equation had to be written by hand. There were no specialized techniques for printing. PostScript wasn't even invented yet at that time, so Donald got really tired of correcting the correctors by himself, because he is a very pedant person, and he likes to have every part of his glyphs in fonts placed correctly, the letters placed correctly, and the braces put in the right rounding angles and so on. So he written a few systems during the period of something like 10 years that will allow him to produce the mathematics, the books, making the layout automatically, and the system is so good that it is still used today. Although the new typesetting system, of course, is not applicable, because it is nothing new at the moment, and a few of assumptions that Knuth made were pretty, at that time were of course very sensible, but now are pretty limiting. We will see, for example, what we are missing from TeX, why we have to use Perl for more advanced things. So generally, TeX is a set of formatting commands which lets you take some boxes. Each box is, for example, a letter, put them neatly one next to the other, put some spaces between the boxes, for example between words, and break all those things into lines and into pages. And that's all what TeX does. It sounds pretty simple, but the algorithms that make everything works fine are pretty complicated, and unfortunately you don't have access to most of these algorithms. You can change, for example, how to define when the page is break and the new page starts, or when the paragraphs begins, on how to break the paragraph into lines. You have access to a lot of strange parameters which drive those algorithms, but you have to obey the rules of the original inventor. And you have a few control macros. What by control I mean something like control structures in programming languages. And a few is really a few. You don't have a lot of things we are used to, like loops and subroutines and so on. So how does it look like? On the left you see pretty much almost complete document written in TeX. You see it's plain text with some special commands started by backslash. You see that new line is not important in TeX, it's just like any white space. So two consecutive lines get glued together. If you want to introduce a new paragraph, you use the command bar, or just leave one empty space, empty line. We also have some formatting commands, maybe font access commands like ldots, which produces the ellipses. And the weather is really great today, right? It's not going to rain, hopefully, anymore. Okay, of course this is a very simple document. We can do much better, and we can define some macros. The macro is the very basic unit of beside token, let's say, but it is very basic unit of processing. And expanding macros is the process that takes most of the time in TeX. Anytime Perl sees some of our commands starting with backslash, it takes the definition and expands it. And if there are more macros inside the expansion, it takes every of those commands and it starts expanding and so on, until it sees only very basic commands like put a box, add horizontal space of two digital points and something like this. So something like ellipses here. Ldot is really a name of the macro in TeX, which gets expanded into a sequence of smaller tokens like simple dots and very carefully chosen distances between those dots. Fortunately, we don't have to think about it, and we have defined our own macros. This is something like variables because they can get redefined. So we define the year 2014 and the place is Poznań, and we can use it just as other macros predefined in TeX by using starting with backslash and the name of the macro. And also we have access to some lower level elements. I mean, not so abstract as macros, but for example, considering the paragraph skip, I mean the additional amount of white space between paragraphs, we have something called length named parskip, and if we set it into half the length, the height of the letter M, we get a nice distance between the paragraphs. So we can steer those. This is an example of a parameter that drives the engine of TeX layout, making layout. We see that a lot of things getting done in the background, like for example breaking the line, hyphenation, and so on. We have access to those to the parameters for those algorithms. We can't change them directly. Okay, instead of inventing our own macros for laying out the very basic things sometimes, people already did it. For us, the most common, the most well-known package of those macros is called LaTeX. And LaTeX idea was to put all those formatting and low-level commands aside and focus on the structure. So LaTeX introduced a lot of structural commands like section, subsection, equation, something we want to see when producing a lot of, for example, scientific papers, where every paper is similar to the other. And behind the scene, LaTeX expands those commands with nicely laid out content. This is the example for example, how simply it is to get math laid out very nicely, which is really appreciated by mathematicians, physicists, and all those scientists who previously had problems with producing those mathematics by hand, or Microsoft Word, for example. And some people think the TeX doesn't have any deficiencies. Of course, it depends on the person who asks, but for some of us, for me, being used to writing in higher level languages, having only conditionals, macros, and tail recursion as the ways to fulfill the requirements of Turing complete machine, because TeX is such a machine, so in fact we can write any program we can write in Perl, in TeX, but trying to do this only with those elements, without any stack, without subroutines, without namespaces, without really advanced math, because natively TeX only has fixed point mathematics, I mean arithmetics. I'm not really ready to do this all the time, so I think programming can get hard and we can do better. And now I'll show you how I think I did better by separating some concerns into and assigning them to tools which are best used to the job. So first, some background. Some time ago, Poznań University of Technology, where I work, had cooperation with NaviExpert, and NaviExpert asked, which is a company who sells navigation systems, and NaviExpert asked us to produce a report about traffic jams in Warsaw. They wanted some PR, some marketing information sent to the press about how many time drivers stand in traffic jams and how much time do they lose. What did NaviExpert gave us was the average speed of travel in Warsaw in every hour of the day. So, for example, we see that in the hours between the midnight and let's say 5 p.m., 5 a.m., the average speed is well above 50. I don't know if it's legal, but that's the data. And the lowest traveling speed is around the morning high peak, it's around 8. And then it gets better for some time, and then we have afternoon peak, and so on. The other graph shows the information about how many people are involved in traveling during these hours. Yeah. And this is the only raw data that we got from NaviExpert. And what we were to do was to get those data, find out some methodology to produce information about how many time does it take for an average driver to travel from one place to another, and how short it would be if there were no no traffic jams. Of course, a lot of assumptions had to be made, a lot of ideas from the scientists were produced, but the general workflow was something like get the data from Navi Expert. It was already done, so easy. Crunch the numbers, statistics in Excel, because, or any other spreadsheet, because this is the easiest way to experiment with the data. Like it or not, that's the truth, and a lot of scientists use Excel as a first shot tool for getting some statistics from the data. Plug those numbers, those statistics into the report. I mean, of course, the TeX report, because TeX is a standard tool for producing journal papers and reports, and publish. Easy peasy. But unfortunately, the steps 1 to 3 get introduced a lot. So, for example, after a few months, we got new data from Navi Expert, which changed a bit because it was before Euro 2012. I mean, the European Championship in football. So the speeds changed, and a lot of new roads were available for drivers, and so on. So we had to recalculate everything. Scientists get a lot of ideas all the time, so the methodology also evolved. So during the time, and those formulas in Excel were getting much harder to get in shape and to understand it all the time, what all those formulas really mean. And we had also the perspective of republication of the report for the next year. So we had to be prepared to putting all those numbers again and again and again in the report. And of course, the risk of forgetting to change some numbers in those reports and so on, was pretty high. So the solution was to split responsibilities and assign every person to the role they are best at. So the engineers gather user data all the time and provided us with new data when that data was available. Scientists sat down and think about the methodology and all the changes, all the impact it could have on the interpretation could have on the reliability of the result. And me automated and published the report, and it was really the nicest part, I think, from all those. 3 parts, 3 pieces were made. First was the DSL for methodology specification. The Excel was at its limits, so I wanted some language in which the scientists could express their methodology to me. It couldn't be Perl because it would be too hard for those people to write everything in Perl. I wrote a Perl script for data mangling and provided the TeX layout for producing the final result. So let's see how those pieces look alike. Methodology DSL looks something like this. This is some part specifying a table of data, in fact a CSV table, which is the very basic format you can get from anyone. We see a variable v, which means the speed, the vehicle speed, in the subsequent hours of the day. So first one is at hour 0, the second one is at hour 1, and so on. And we also see a specification of format. The format is something that goes into the final TeX report. Although this is a C format, printf format, so you may say that it is incompatible with the data, but the input data is one thing, and the output of those data to the TeX is another thing. So, for example, if you want to have higher resolution, we use 4 digits of, 6 digits of information here as the input data, but for the report we only need 2 digits after the dot, so the decimal dot, so that's why the format is dot to F. Yeah? So this is a simple table of data. We also have formulas, simple loops. When we iterate for every hour, we calculate how long it takes to travel 1 kilometer from the information in vehicle speed. We also have the simple table for probabilities that some driver drives in a specific hour of the day. And we have also all those methodological rules specified previously in Excel translated into nicer or less nice expressions. It's something, the whole specification of the methodology is something like 100 interleaved formulas, so you can see that navigating all those formulas in Excel can be really daunting and is not a pleasant task. So, extracting this to those DSL text files was really necessary.
Excuse me, so are you
Yeah?
saying that this was generated based on...
No, this was made by hand, by jumping from one cell to the other in Excel and writing down all those information that was left by someone before. It was like making a graph of dependencies between cells and writing, giving them some names and then writing those names in formulas. Fortunately, you can see the result with very informative names, because at the beginning it was just 24 and so on, some names in Excel. Later it was translated to some English. And we also have some definition of formats. Format is a way of expressing value to the outer world in this way, in this example to TeX. So for example, sometimes we want some number to be specified in thousands or in millions when we want to cut the least significant digits and so on. For example, we have an example of number of people in Warsaw, which is 2,430,000. And in the report we want to specify as 2,430,000. Yeah? So we apply a format of thousands to the value. So this is really only affecting the output. So the Perl script result is really a piece of TeX code. What you see here is a bunch of results from processing the DSL definition, and we for every definition we take one, we calculate the value and create one macro. So for example, we define macro V0 being 53.12 and so on. So at the top you have the plain table. At the bottom you have all the values from the calculated formulas. And the TeX template is really a nice piece of unchangeable code, because TeX code, because it needed to be changed. Every single number which appears in TeX template was replaced with a reference to some variable. So when data changes, nothing has to be done in the template. So we see that all those information, besides maybe the hours of the day, which I don't think will change anytime soon. We always have 24 hours of the day. Besides that, everything is a reference to some value calculated externally in Perl. So the end result is a clean separation of consensus, which reminds me of MVC, because we can call the DSL a model. V is for us the TeX output, and the controller is the Perl script, which binds them together. Since the introduction of this separation, we produced 3 different reports generated without major changes to any other part than good data. And in fact, also the graphs you've seen previously was also generated automatically by the means of this DSL and TeX templating. And of course, time spent coding part for me is much more pleasant than coding TeX because everything was much more expressible and the results were much nicer. And this is how those numbers got produced in the output PDF. You can imagine what would it be like if you have to exchange every single number, which is something like 150 in case of this report. Also, if you want to see the full report, it's publicly available. The URL is on the bottom. Okay, that's all I have for you today. If you have any questions?
Is the DSL available somewhere?
Yes, in the Perl script.
Okay, but is it published or is it like private?
It's private to me right now. There's no restrictions. I may publish it someday, but in fact it was a hacking session of a few nights to do this, so you can imagine how bad the code is. And I didn't use any high-level tools like grammars or Marpa or something like this, so it can get better.
Okay.
So it's not in a good shape. I probably had made some changes to show it to the world. So.
Okay.
There's an, of course, but maybe not now.